You know, when we look up at the night sky, Venus shines like a brilliant diamond against the darkness. The ancient Romans named it after their goddess of love and beauty, and honestly, from here on Earth, it really does look like the most gorgeous celestial object we can see. But here's the thing that absolutely blows my mind about space exploration. Sometimes the most beautiful things from a distance turn out to be the most terrifying up close. Picture this. It's the 1960s, and we're in the middle of the space race. The Soviet Union and the United States are racing to explore our neighboring planets, and Venus seems like the obvious first choice. After all, it's roughly the same size as Earth. It's our closest planetary neighbor, and those thick, creamy clouds make it look almost inviting. Scientists were genuinely excited about what they might find beneath that mysterious veil. The first real shock came when the Soviets sent their early Venera probes in the late 1960s. These weren't just fly-by missions. They were designed to actually land on the surface and send back data. But mission after mission kept failing in the most dramatic ways. The probes would work perfectly during their journey through space, then suddenly go silent as they descended through Venus's atmosphere. At first, engineers thought it was just bad luck or technical problems. But slowly, a horrifying picture began to emerge. The atmosphere wasn't just thick, it was impossibly dense, pressing down with 90 times the pressure we experience on Earth. Imagine being crushed under nearly a mile of ocean water, and you're getting close to what any spacecraft faces on Venus's surface. And then there was the temperature. The first successful readings seemed so extreme that scientists thought their instruments were malfunctioning. How could any planet be 900 degrees Fahrenheit? That's hot enough to melt lead, zinc, even some types of brass. The surface of Venus is literally hotter than Mercury, even though Mercury sits much closer to the sun. But the real kicker? Those beautiful, pearlescent clouds that make Venus look so elegant from Earth. They're made of concentrated sulfuric acid. We're talking about clouds so corrosive they could dissolve metal in minutes. Rain does fall from these clouds, but it's acid rain so intense that it evaporates completely before ever reaching the ground, creating this perpetual cycle of chemical horror in the middle atmosphere. The Soviet engineers, bless their persistence, kept trying. They built the Venera landers like miniature tanks, with titanium shells and cooling systems that would make a refrigerator jealous. Most of these incredibly tough machines lasted less than an hour on Venus's surface before the environment destroyed them completely. The few that managed to send back pictures showed a landscape that looked like something from our worst nightmares about hell. Jagged rocks, an orange-tinted sky, and an atmosphere so thick that sunlight barely penetrates to create this perpetual dim twilight. Here's what really gets me thinking, though. Venus and Earth formed from the same cosmic neighborhood, from the same disk of dust and gas around our young sun. For the first few 100 million years, they probably looked remarkably similar. Both had water, both had atmospheres, both were potentially habitable worlds. So what went wrong? The story that scientists have pieced together is like a cosmic cautionary tale about climate change. Venus sits just a little closer to the sun than Earth does, maybe 30% closer. That small difference meant it received just a bit more solar energy. At first, this wasn't a problem. Venus had oceans, probably for hundreds of millions of years. But here's where things get interesting and terrifying at the same time. As the sun gradually grew brighter over billions of years, Venus started receiving more and more heat. The planet's oceans began evaporating faster than they could condense back into rain. Water vapor is actually a greenhouse gas, so more water in the atmosphere meant more heat got trapped. This created a runaway effect. More heat led to more evaporation, which led to more greenhouse warming, which led to even more evaporation. Eventually, Venus lost all its water to space. The hydrogen from water molecules escaped into the cosmos, leaving behind a bone-dry planet with an atmosphere that was almost pure carbon dioxide. Carbon dioxide is an even more powerful greenhouse gas than water vapor, so Venus kept getting hotter and hotter until it reached the infernal temperatures we see today. The whole process probably took millions of years, but once it started, there was no going back. Any life that might have existed on early Venus would have faced an impossible choice: evolve to survive in increasingly extreme conditions, or perish completely. As far as we know, nothing survived the transformation. But Venus had one more surprise waiting for us, something so weird that it took scientists years to believe their own data. The planet spins backwards. While Earth and most other planets rotate counterclockwise when viewed from above their north poles, Venus rotates clockwise. Not only that, but it rotates incredibly slowly, taking 243 Earth days to complete just one rotation. A day on Venus is actually longer than a Venus year, which lasts only 225 Earth days. Nobody knows for certain why Venus spins this way. The most popular theory suggests that during the early chaotic period of our solar system's formation, Venus was struck by a massive object, possibly as large as a small planet. This collision was so powerful that it actually reversed the planet's rotation and slowed it down to the crawling pace we observe today. What makes this discovery even more fascinating is thinking about what Venus's strange rotation means for someone standing on its surface. If you could somehow survive the crushing pressure, the acid atmosphere, and the lead-melting heat, you would see the sun rise in the west and set in the east. But you'd have to wait almost 4 months between sunrise and sunset, experiencing a day-night cycle unlike anything we can imagine on Earth. Recent discoveries have made Venus even more intriguing. Scientists have found evidence of active volcanism, with massive volcanic regions that might still be erupting today. The planet's surface shows signs of being completely resurfaced by volcanic activity sometime in the past 500 million years, which in geological terms is relatively recent. Even more exciting, researchers have detected traces of phosphine gas in Venus's upper atmosphere, about 30 miles above the surface, where conditions are actually somewhat Earth-like in terms of temperature and pressure. On Earth, phosphine is almost exclusively produced by living organisms or industrial processes. Finding it on Venus has sparked intense debates about the possibility of aerial life, microorganisms that might exist floating in the planet's upper atmosphere, far above the hellish surface conditions. The story of Venus serves as both a warning and a source of wonder. It shows us how dramatically a planet can change, how a world that might once have been as beautiful and habitable as Earth can transform into something completely alien. At the same time, it demonstrates the incredible power of scientific exploration and human curiosity. Every mission to Venus, from those early Soviet landers to the more recent orbital surveys, has revealed new layers of complexity about our sister planet. We've learned that planetary evolution isn't always gradual and predictable. Sometimes, worlds can cross tipping points that lead to irreversible changes, transforming paradise into purgatory in cosmic terms that span millions of years but represent mere moments in the life of a planet. As we continue to study Venus and plan future missions, including possible floating research stations that could operate in the more hospitable upper atmosphere, we're not just learning about another world. We're gaining crucial insights into how planets work, how atmospheres evolve, and how the delicate balance that makes Earth habitable could potentially change. Venus reminds us that in space, beauty and terror often exist side by side, separated only by distance and perspective. From Earth, it remains that brilliant evening star, a beacon of light in our sky. But up close, it stands as one of the most extreme environments in our solar system, a world that challenges our understanding of what's possible and keeps us humble about our place in the vast, surprising cosmos. You know what absolutely fascinates me about Venus? If we could travel back in time about 4 billion years ago, we might have found ourselves looking at two remarkably similar worlds. Picture this: early Venus and early Earth. Both young planets still cooling down from their violent formation, both receiving water from countless comet impacts, both developing their first primitive atmospheres. Scientists believe that during those early days, Venus actually had vast oceans covering much of its surface. Can you imagine that? Standing on ancient Venus, you might have seen endless blue waters stretching to the horizon, white clouds drifting overhead, and temperatures that would have felt pleasantly warm rather than lethally hot. It's almost heartbreaking to think about how different things could have been. The tragedy of Venus is that it started with all the right ingredients for life. It had water, it had a reasonable atmosphere, and it was receiving energy from the sun. For hundreds of millions of years, maybe even longer, Venus might have been what we'd call a habitable world. Some scientists even speculate that if life had enough time to develop there, we might have had neighbors in our own solar system. But here's where the story takes a dark turn. And it's a story that should make all of us think carefully about our own planet. Venus sits about 25 million miles closer to the Sun than Earth does. That might not sound like much when we're talking about the vast distances of space, but in terms of planetary climate, it's absolutely crucial. As our Sun gradually grew brighter over billions of years, that extra solar energy hitting Venus began to make a difference. The planet's oceans started evaporating more quickly than they could condense back into rain. Now, here's the really important part. Water vapor is actually a greenhouse gas. The more water vapor that accumulated in Venus's atmosphere, the more heat got trapped near the surface. This created what scientists call a runaway greenhouse effect, and it's one of the most terrifying processes in planetary science. More heat led to more evaporation, which led to more water vapor in the atmosphere, which trapped even more heat, which caused even more evaporation. It was a feedback loop with no escape route. As this process continued over millions of years, something even more dramatic happened. The intense heat began breaking apart water molecules high in the atmosphere. The hydrogen atoms, being so light, escaped into space forever, while the oxygen either escaped as well or combined with rocks on the surface. Slowly but surely, Venus was losing all its water to the cosmos. But losing the oceans was just the beginning of Venus's transformation into hell. As the water disappeared, massive amounts of carbon dioxide that had been dissolved in the oceans got released into the atmosphere. Carbon dioxide is an even more powerful greenhouse gas than water vapor, so Venus's atmosphere became increasingly thick and heat-trapping. The process kept accelerating. Volcanic activity triggered by the planet's internal heat and possibly by the stress of losing so much water pumped even more carbon dioxide into the atmosphere. The surface temperature climbed higher and higher until it reached the 900 degrees Fahrenheit we see today. What really gets me is thinking about how long this process took. We're not talking about something that happened overnight or even over a few thousand years. This transformation probably unfolded over tens of millions of years, maybe longer. If there had been any form of life on early Venus, it would have experienced climate change so gradual that thousands of generations might have passed before the changes became truly noticeable. But by then, it would have been far too late to do anything about it. Once Venus crossed certain tipping points in its atmospheric composition and temperature, there was no going back. The planet was locked into its current state of being a furnace world, with an atmosphere so dense it would crush any visitor from Earth. Here's what makes this story even more sobering. The same process could theoretically happen to Earth. We're protected by our distance from the Sun, but that protection isn't absolute. As our Sun continues to age and gradually grows brighter, Earth will eventually receive enough extra energy to start the same runaway greenhouse process that destroyed Venus. Fortunately for us, we're talking about events that won't happen for another billion years or so. But the Venus story shows us just how delicate the balance really is that keeps our planet habitable. We exist in what scientists call the habitable zone, sometimes nicknamed the Goldilocks zone, where it's not too hot and not too cold for liquid water to exist on the surface. What if Earth had formed just a little closer to the Sun? What if our early atmosphere had been slightly different? What if we hadn't had the Moon to help stabilize our climate? Any of these factors could have sent us down the same path as Venus, transforming our blue marble into another acid-shrouded inferno. The story becomes even more thought-provoking when we consider that we're currently conducting our own atmospheric experiment on Earth. We're adding carbon dioxide to our atmosphere at an unprecedented rate, and while we're nowhere near Venus levels, we're seeing the early stages of enhanced greenhouse warming. Venus serves as the ultimate cautionary tale about what can happen when greenhouse gases accumulate beyond a planet's ability to regulate its temperature. But here's something incredible to consider. Studying Venus is actually helping us understand our own planet better. By learning how Venus's climate system collapsed, scientists are gaining crucial insights into how Earth's climate works and what we need to do to protect it. Every probe we send to Venus, every measurement we take of its atmosphere, teaches us something new about the delicate mechanisms that keep our own world livable. The most recent discoveries about Venus are making the story even more complex and fascinating. Some scientists now think that Venus might have remained habitable much longer than we previously believed, possibly for as long as 3 billion years. If that's true, it means Venus had plenty of time for life to develop and evolve before the runaway greenhouse effect finally took hold. There's even speculation that if Venus had been able to hold on to some of its water, if certain factors had been different, it might still be habitable today. Instead of being Earth's evil twin, it could have been Earth's beautiful sister, another blue world where we might have eventually found neighbors among the stars. The tragedy of Venus is that it shows us how a single factor, proximity to our energy source, can determine the entire fate of a world. Venus didn't fail because it was poorly designed or unlucky. It failed because it was born just a little too close to the sun for its own good. And once the process of atmospheric collapse began, physics took over and sealed its fate. When we look at Venus shining in our evening sky, we're not just seeing another planet. We're seeing a ghost of what Earth could have been, a reminder of how precious and fragile our own world really is. It's a sobering thought, but also an inspiring one, because it reminds us that we live on something truly special. A planet that won the cosmic lottery and ended up in just the right place at just the right time to nurture life. And that makes protecting our Earth not just important, but absolutely essential. After all, we've seen what happens when a planet loses its way. Imagine stepping onto a world where the very air would crush you instantly, and the heat would melt your bones in seconds. This isn't science fiction. This is Venus, our neighboring planet that serves as nature's most terrifying warning about what happens when a greenhouse effect spins completely out of control. Picture this. You're standing on Earth at sea level, feeling the normal weight of our atmosphere pressing down on you at about 14 7/10 pounds per square inch. Now imagine diving deep into the ocean, going down and down until you're more than 3,000 feet below the surface. The crushing pressure at that depth is exactly what you'd feel just standing on Venus's surface, 92 times heavier than what we experience here on Earth. Your body would be compressed like an empty soda can under a steamroller. But the pressure is just the beginning of this planetary horror story. The temperature on Venus reaches 865 degrees Fahrenheit, hot enough to melt lead into liquid puddles. To put this in perspective, your kitchen oven at its highest setting reaches maybe 500 degrees. Venus is nearly twice as hot as that, everywhere, all the time. There's no escape from this infernal heat, no cool polar regions, no refreshing nights. The thick atmosphere traps heat so efficiently that even the dark side of the planet, which doesn't see sunlight for months, remains blazing hot. The atmosphere itself reads like a chemist's nightmare. Those beautiful pearlescent clouds that make Venus shine so brightly in our evening sky. They're made of concentrated sulfuric acid, the same corrosive chemical that can eat through metal and dissolve organic matter in minutes. Rain does fall from these acid clouds, but it's so incredibly hot that the droplets evaporate completely before ever reaching the ground, creating an eternal cycle of acidic vapor. Carl Sagan, the renowned astronomer who helped us understand the cosmos, once called Venus a cosmic warning about the dangers of runaway greenhouse effects. He wasn't being dramatic, he was being prophetic. Venus likely started much like Earth, with oceans and a more moderate climate. But something went catastrophically wrong in its atmospheric evolution. The planet's thick carbon dioxide atmosphere began trapping more and more heat from the sun. As temperatures rose, any water that existed began evaporating, and water vapor is itself a powerful greenhouse gas. This created a vicious cycle. More heat led to more water vapor, which led to even more heat. Eventually, all the water was lost to space, leaving behind only the suffocating blanket of carbon dioxide that now makes Venus the hottest planet in our solar system, even hotter than Mercury despite being much farther from the sun. What makes Venus's story particularly chilling is how it demonstrates the delicate balance required for a planet to remain habitable. Venus sits just a little closer to the sun than Earth does, about 25 million miles closer. That seemingly small difference was enough to trigger a chain reaction that transformed what might have been a twin of Earth into an uninhabitable hellscape. Scientists believe that billions of years ago, Venus might have had oceans and conditions suitable for life. But those days are long gone, buried under an atmosphere so dense and toxic that even our most advanced spacecraft can only survive on its surface for a few hours before being crushed and corroded into scrap metal. The story of Venus serves as a sobering reminder of how precious and fragile our own planet's climate really is. While Earth has found its perfect balance, maintaining temperatures that allow water to exist in all three states, and supporting the incredible diversity of life we see today, Venus shows us what happens when that balance is lost forever. Here's something that will absolutely blow your mind about Venus. Imagine waking up every morning for almost 8 months straight, and the sun is still in exactly the same position in the sky. That's what a single day feels like on Venus, because one rotation of the planet takes 243 Earth days to complete. To put this in perspective, you could be born, graduate from high school, and start college all within a single Venusian day. But here's where things get really weird. While Venus takes 243 Earth days to spin once on its axis, it only takes 225 Earth days to complete one orbit around the Sun. This means that a day on Venus is actually longer than a year on Venus. Let that sink in for a moment. The planet finishes an entire trip around the Sun before it even completes one full rotation. It's like a cosmic joke that defies everything we think we know about how planets should behave. Now, if that wasn't strange enough, Venus has another trick up its sleeve that makes it the rebel of our solar system. While nearly every other planet spins in the same direction they orbit the Sun, what astronomers call prograde rotation, Venus spins backward. If you could somehow survive standing on Venus's surface and looking up through those acid clouds, you would witness something no human has ever seen from Earth: the Sun rising in the west and setting in the east. Picture this bizarre scenario. You're watching a Venusian sunrise, but instead of appearing where your Earth-trained brain expects it to, the Sun slowly emerges from what should be the sunset direction. Everything feels backward, upside down, wrong. It's as if the entire planet decided to thumb its nose at the cosmic order that governs the rest of our solar neighborhood. Scientists have spent decades trying to solve the mystery of Venus's backwards rotation, and their leading theories read like the plot of a disaster movie. The most compelling explanation involves a catastrophic collision early in Venus's history. Imagine a Mars-sized object hurtling through space billions of years ago, slamming into the young Venus with such tremendous force that it literally flipped the planet upside down. The impact would have been so violent that it changed the planet's entire rotational destiny forever. But there's another possibility that's equally fascinating. Venus might have been gradually slowed down and then reversed by the complex gravitational dance between the Sun and its own incredibly thick atmosphere. Over millions of years, these forces could have acted like cosmic brakes, first slowing Venus's normal rotation to a crawl, then actually reversing it entirely. It's like watching a spinning top slowly lose momentum, wobble, and then start spinning the other way. The slow rotation has profound effects on Venus's weather patterns too. On Earth, our 24-hour day creates regular cycles of heating and cooling that drive our weather systems. But on Venus, with its incredibly long days, the atmosphere has time to reach a kind of thermal equilibrium. The result is a planet with remarkably uniform temperatures. That hellish 865 degrees Fahrenheit we talked about earlier stays constant, whether you're on the day side or night side of the planet. This also means that Venus experiences the most extreme seasonal variations imaginable, but not in the way you might think. Instead of hot summers and cold winters, Venus has day seasons that last for months, followed by equally long night seasons. During the day season, one side of the planet bakes under the sun's rays for over 4 months straight, while the other side remains in darkness for the same period. What makes Venus's rotation even more mind-boggling is how it affects the planet's magnetic field, or rather, its lack of one. Earth's relatively fast rotation helps generate our protective magnetic field through the movement of molten metal in our core. But Venus's incredibly slow spin means it can't generate a significant magnetic field, leaving the planet completely exposed to the solar wind and cosmic radiation. The story of Venus's rotation reminds us just how chaotic and violent the early solar system must have been. Planets weren't born into their current orbits and rotations. They were shaped by billions of years of cosmic collisions, gravitational tugs of war, and forces so powerful they could flip entire worlds upside down. Venus stands as a permanent reminder that in space, the impossible can become reality, and the rules we think we understand can be rewritten by the raw power of physics unleashed on a planetary scale. Every time we look up at Venus shining in our evening sky, we're looking at a world where time moves differently, where the sun rises in the wrong direction, and where a single day lasts longer than an entire year. It's a cosmic riddle that continues to challenge our understanding of how planets form and evolve, wrapped in the beautiful, mysterious glow of our nearest planetary neighbor. Picture this. You're planning a vacation to what seems like Earth's twin sister. Venus is roughly the same size as our planet, sits relatively close to us in cosmic terms, and was once thought to be a tropical paradise hidden beneath those mysterious clouds. But as soon as you step off your spacecraft, you'd be crushed, cooked, and dissolved all at the same time. Welcome to Venus, the most hostile neighborhood in our solar system. The story of exploring Venus reads like a series of heroic attempts, followed by spectacular failures. Back in the 1960s, when the space race was heating up, both American and Soviet scientists were eager to unlock the secrets of our planetary neighbor. The Americans focused on flyby missions, snapping pictures from a safe distance. But the Soviets? They decided to go all in and land right on the surface. The Venera program became one of the most ambitious and frankly audacious space exploration efforts ever attempted. Imagine the engineers sitting around tables in Moscow, trying to design a spacecraft that could survive what they were slowly discovering was essentially a vision of hell. The surface temperature on Venus reaches about 860 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is 90 times greater than Earth's, equivalent to being crushed under 3,000 feet of ocean water. And if that wasn't enough, the atmosphere is filled with sulfuric acid clouds that would eat through metal like a hungry monster. The first few Venera missions in the early 60s didn't even make it to Venus. Some failed during launch, others lost communication along the way. It was like trying to send a message in a bottle across a stormy ocean, except the ocean was space and the storm was the technological limitations of the era. But the Soviets kept trying, learning from each failure, each lost spacecraft, teaching them something new about the journey ahead. Then came Venera 7 in 1970. And for the first time in human history, a spacecraft successfully transmitted data from the surface of another planet. The signal lasted just 23 minutes before the probe was silenced forever. But those precious minutes provided the first direct measurements of Venus's surface conditions. The scientists listening to those faint radio signals must have felt like they were receiving dispatches from an alien world, which in many ways they were. Venera 9 and 10 followed a few years later, and these missions managed something truly extraordinary. They sent back the first photographs from the surface of Venus. The images showed a rocky, desolate landscape that looked like the aftermath of some cosmic catastrophe. The spacecraft survived for about an hour each, just long enough to capture these ghostly glimpses of our neighbor's surface before succumbing to the brutal environment. The most successful of the Venera missions, Venera 13, managed to survive for over 2 hours in 1982. It was like a marathon runner in the most extreme conditions imaginable, transmitting data and images while slowly being destroyed by the very world it was trying to study. The engineering triumph of these missions cannot be overstated. Soviet scientists essentially created spacecraft that were like armored submarines designed to operate in a pressure cooker filled with acid. But why is Venus so impossibly hostile? The planet is a cautionary tale about runaway greenhouse effects. Scientists believe Venus once had oceans, just like Earth. But something went terribly wrong. The sun's energy began heating the planet's surface, causing water to evaporate. Water vapor is a greenhouse gas, so more heat meant more water vapor, which meant even more heat. It was a vicious cycle that spiraled completely out of control. As the water boiled away into space, carbon dioxide built up in the atmosphere, creating an even more powerful greenhouse effect. The sulfur in Venus's rocks began vaporizing, creating those deadly sulfuric acid clouds. What might have once been Earth's twin became a hellscape that makes the most extreme environments on our planet seem like pleasant vacation spots. Today, decades after the last Venera mission, scientists are preparing for a new chapter in Venus exploration. NASA's Da Vinci Plus mission, planned for the late 2020s, will dive through Venus's atmosphere like a high-tech meteorite, analyzing the chemical composition of those mysterious clouds as it falls toward the surface. It's named after Leonardo da Vinci, the Renaissance genius who dreamed of flight centuries before it became possible. Meanwhile, the Veritas mission will use advanced radar to map Venus's surface from orbit. Peering through those thick clouds, to reveal the planet's geology in unprecedented detail. These missions represent a quantum leap forward from the brave Venera probes, equipped with modern technology that can withstand Venus's extremes far longer and gather vastly more information. The story of Venus exploration reminds us that sometimes the most important discoveries come from the most challenging journeys. Every failed mission, every spacecraft crushed by Venus's brutal environment, every signal lost in the cosmic darkness contributed to our understanding of not just Venus, but of planetary science itself. The lessons learned from studying Venus help us understand climate change on Earth, the formation of rocky planets throughout the universe, and the delicate balance that makes life possible on our own world. As we prepare for these new missions to Venus, we're not just satisfying scientific curiosity. We're continuing one of humanity's greatest adventures, the quest to understand our place in the cosmos, one hostile planet at a time. Venus may be Earth's evil twin, but studying it helps us appreciate just how special and fragile our own planet really is. Sometimes the most extraordinary discoveries happen when scientists are looking for something completely different. That's exactly what happened to astrobiologist Jane Greaves and her team in 2020 when they pointed their telescopes toward Venus expecting routine atmospheric measurements and instead stumbled upon one of the most intriguing mysteries in modern astronomy. Greaves had been studying Venus's atmosphere using radio telescopes, mapping the chemical signatures hidden within those thick, swirling clouds. It was meticulous work, the kind that requires patience and precision. She was analyzing data from the James Clerk Maxwell telescope in Hawaii when something unusual caught her attention. There, buried in the spectral data, was an unmistakable signature of phosphine gas floating high in Venus's atmosphere. At first, Greaves and her team thought they'd made a mistake. They double-checked their calculations, re-examined their data, and even used a different telescope, the powerful ALMA Observatory in Chile, to confirm their findings. But the signal was real. Venus's clouds contained phosphine, and that discovery sent shockwaves through the scientific community. Here's why this tiny molecule caused such a stir. On Earth, phosphine is incredibly rare in nature. You won't find it floating around in our atmosphere under normal conditions because it gets destroyed quickly by oxygen and sunlight. The only ways we know phosphine gets produced on our planet are through industrial processes or by certain microorganisms living in oxygen-free environments like swamps, sewage treatment plants, or the intestines of animals. In other words, phosphine is what scientists call a biosignature, a chemical that strongly suggests the presence of life. The discovery hit the scientific world like lightning. Imagine being told that your notoriously hostile neighbor, the one everyone avoids because their house is literally on fire and filled with acid, might actually be harboring secret life forms. That's essentially what Greaves was suggesting about Venus. But she was careful with her words, emphasizing the uncertainty inherent in such a momentous claim. "We're not saying that it's life," Greaves explained to reporters and fellow scientists, "but it's a possibility that we cannot ignore." Her cautious approach reflected the enormous weight of what this discovery could mean. Finding life on Venus would revolutionize our understanding of biology, chemistry, and the potential for life throughout the universe. But how could anything possibly live on Venus? The surface conditions are absolutely lethal, as we've established. However, Venus's upper atmosphere, about 30 to 40 miles above the surface, tells a different story. Up there, temperatures drop to a relatively balmy range of 0 to 140 degrees Fahrenheit. The atmospheric pressure becomes much more manageable, and while the environment is still incredibly acidic, it's not immediately fatal. Scientists began imagining scenarios that seemed straight out of science fiction. Perhaps microscopic organisms could float in Venus's clouds, suspended in tiny droplets of sulfuric acid, somehow thriving in conditions that would kill any known Earth life instantly. These hypothetical microbes would need to be incredibly resilient, possessing unique biochemistry that could not only tolerate, but actually utilize the harsh chemical environment around them. The idea wasn't entirely far-fetched. Here on Earth, we've discovered life in the most extreme environments imaginable. Scientists have found bacteria thriving in boiling hot springs, in the acidic waters of volcanic lakes, in the deep ocean where pressure would crush a submarine, and even in the radioactive zones around nuclear reactors. Life, it seems, has an almost supernatural ability to adapt and survive in places we once thought were completely sterile. But the phosphine discovery on Venus faced immediate scrutiny. Other scientists began questioning the findings, proposing alternative explanations for the mysterious gas. Some suggested that volcanic activity could produce phosphine through previously unknown chemical processes. Others hypothesized that lightning in Venus's atmosphere might create the right conditions for phosphine formation without any biological involvement. The debate intensified when follow-up studies using different telescopes and analysis methods produced conflicting results. Some research teams claimed they couldn't detect phosphine at all, while others found much lower concentrations than originally reported. The scientific community found itself divided, with passionate arguments on all sides about methodology, data interpretation, and the extraordinary claims being made. This uncertainty reflects one of the fundamental challenges in astrobiology, the search for life beyond Earth. When you're looking for something as profound as extraterrestrial life, the burden of proof becomes enormous. Scientists must eliminate every possible non-biological explanation before they can even begin to seriously consider biological ones. It's like being a detective investigating the crime of the century, where every piece of evidence must be absolutely bulletproof. The phosphine mystery also highlights how little we still understand about Venus's complex atmospheric chemistry. Despite decades of study, Venus remains surprisingly enigmatic. The planet's thick clouds hide most of its secrets, and the extreme conditions make detailed exploration incredibly difficult. We're essentially trying to solve a puzzle while wearing blindfolds and thick gloves. Meanwhile, the discovery has energized the scientific community in unexpected ways. Researchers who had never considered Venus as a potential habitat for life suddenly found themselves designing new experiments and proposing innovative missions. The European Space Agency accelerated planning for their Envision mission, while private companies began exploring the possibility of atmospheric probes specifically designed to hunt for biosignatures in Venus's clouds. The phosphine debate also sparked broader discussions about what constitutes evidence of life and how we should approach the search for extraterrestrial organisms. If microbial life could exist in Venus's clouds, what other seemingly impossible environments might harbor living creatures? Could there be floating ecosystems in the atmospheres of gas giant planets? Might life exist in forms so alien that we wouldn't recognize it, even if we were looking directly at it? As research continues, the Venus phosphine mystery serves as a reminder of how much we still don't know about our own solar system. Here's a planet that's been studied for decades, our closest planetary neighbor, and yet it can still surprise us with discoveries that challenge our most basic assumptions about where life can and cannot exist. Whether or not the phosphine signal ultimately proves to be biological, the discovery has already changed how we think about Venus and the potential for life in extreme environments. It's shown us that even the most hellish worlds might hold secrets worth investigating, and that the universe might be far stranger and more alive than we ever dared to imagine. So what do you think? Could there really be tiny organisms floating in Venus's acidic clouds, defying everything we thought we knew about the limits of life? The answer might reshape our understanding of biology itself. Picture this. You're standing in ancient Rome, watching the evening sky as the first star appears. It's not actually a star, though. It's Venus, burning bright like a celestial jewel. The Romans called her Venus, goddess of love and beauty. And honestly, you can understand why. She's absolutely stunning up there, outshining everything except the moon itself. But here's where the story gets really interesting. Those same ancient people had no idea they were gazing at what we now know is essentially hell with an atmosphere. Venus today represents one of the most dramatic transformations in human understanding, from divine beauty to toxic nightmare. Think about it for a moment. Ancient cultures across the world looked up at this brilliant point of light and saw femininity, love, and divine grace. The Greeks called her Aphrodite. The Babylonians named her Ishtar. There was something universally captivating about this celestial body that made nearly every civilization associate it with their most powerful goddesses. The Maya took this fascination even further. They didn't just worship Venus. They used her movements to plan their entire lives. When Venus appeared in certain positions, it was time for war. When she shifted elsewhere in the sky, It marked religious ceremonies. Imagine organizing your battles and sacred rituals around what you thought was a goddess, not knowing you were actually following the orbit of a planet where lead would melt on the surface. This disconnect between perception and reality creates such a fascinating human story. For thousands of years, poets wrote love sonnets inspired by Venus. Artists painted her as the epitome of beauty. Lovers made wishes on her light, all while she was actually a world of sulfuric acid clouds and crushing atmospheric pressure that would kill you in seconds. Then science came along and flipped everything upside down. Suddenly, our goddess of love became the poster child for planetary disaster. The same Venus that inspired countless romantic tales became the setting for science fiction horror stories. Hollywood turned her into a place of failed colonization attempts and terrifying alien creatures. The beautiful evening star transformed into a cautionary tale about runaway greenhouse effects and atmospheric collapse. But here's what's truly remarkable about this whole story. When we finally learned the truth about Venus, that she's hot enough to melt copper, wrapped in clouds of acid, with atmospheric pressure that would crush a human instantly, somehow that made her even more fascinating than the myths ever did. The ancient Romans saw beauty in Venus because they could only imagine what she might be like. We see wonder in Venus because we know exactly how extreme and alien she really is. In a strange way, both perspectives capture something true about human nature. We're drawn to mystery, whether it's the mystery of not knowing or the mystery of understanding just how incredible and hostile other worlds can be. Venus shows us how science doesn't destroy wonder. It just changes what we're wondering about. Instead of asking whether the goddess will bless our love lives, we're now asking how a planet so similar to Earth could become so completely uninhabitable. Instead of using her position to plan ceremonies, we're studying her to understand climate change on our own world. The transformation of Venus in human consciousness reflects our own evolution as a species. We went from being people who created beautiful stories to explain what we saw, to being people who uncover beautiful truths about what actually exists. And somehow, the real Venus, this hellish, fascinating, utterly alien world spinning beneath those brilliant clouds, is even more captivating than any goddess we ever imagined. That's the real magic of Venus. She reminds us that reality, when we finally discover it, is often stranger and more wonderful than any myth we could have dreamed up. So here we are, at the end of our journey through Venus's story, and I have to say, this planet has taught me something pretty incredible about how fragile and precious our own world really is. Think about it this way. Venus and Earth started out as cosmic twins. They formed around the same time, from the same stellar nursery, with remarkably similar sizes and compositions. They were like two seeds planted in the same garden. But somewhere along the way, Venus took a completely different path, and that path led to absolute devastation. The scary part isn't just that Venus became uninhabitable, it's how easily it happened. Scientists believe that small changes in Venus's distance from the Sun, combined with volcanic activity and atmospheric chemistry, created a runaway greenhouse effect that turned the entire planet into an oven. We're talking about a world that might have once had oceans, maybe even conditions suitable for life, transformed into a place where the surface temperature could melt zinc. This isn't some distant abstract concept either. As we're sitting here on Earth, watching our own climate change unfold, Venus stands as this haunting reminder of what can happen when atmospheric systems spiral out of control. It's like having a neighbor whose house burned down because of a small electrical problem that got out of hand. Suddenly, you're very aware of every wire in your own home. And yet, here's the beautiful irony of human nature. While Venus serves as this cosmic warning sign, we're simultaneously dreaming bigger than ever before. We're making serious plans to colonize Mars, designing spacecraft for interstellar travel, and imagining futures among the stars. It's as if Venus's lesson about planetary fragility has made us even more determined to become a multiplanetary species. There's something deeply moving about this human response. Instead of being paralyzed by the knowledge of how hostile the universe can be, we're inspired to explore it. Venus shows us the extremes that planets can reach: crushing pressure, acid rain, temperatures that would vaporize most metals. And somehow, that makes us more curious, not less. Maybe that's the real lesson Venus offers us. It's not just about being careful with our own planet, though that's certainly important. It's about understanding that the universe is full of wonders and terrors beyond our imagination, and that makes our existence here on Earth both more precious and more miraculous. Every time you step outside and feel a gentle breeze, or watch clouds drift peacefully across the sky, or simply breathe without thinking about it, you're experiencing something that Venus lost long ago. Our atmosphere isn't just air. It's this incredibly delicate balance that keeps us alive. Our weather isn't just weather. It's a complex dance of forces that could, under different circumstances, become something utterly destructive. Venus reminds us that we live in a universe of extremes, where small changes can have enormous consequences, where beauty and terror often wear the same face. But instead of making us feel small or frightened, this knowledge can make us feel more connected to the cosmos and more grateful for the remarkable world we call home. As we continue reaching for the stars, planning missions to Mars and beyond, Venus will always be there in our sky, that brilliant point of light that once inspired love poems and now inspires climate science. She's our cosmic teacher, showing us both the fragility of worlds and the resilience of human curiosity. The next time you see Venus shining in the evening sky, remember her story. Remember how she transformed from goddess to warning sign to inspiration. And remember that in a universe full of hostile worlds and impossible distances, we somehow ended up on this one perfect planet, spinning through space with just the right conditions for life, love, and the endless human drive to explore what lies beyond our own small corner of the cosmos. That's the gift Venus gives us. Not just knowledge about other worlds, but a deeper appreciation for our own.